Good afternoon again, and welcome again to the Hannover Messe Hydrogen Fuel Cells and Batteries Group exhibit. My name is Robin, and this afternoon I will be speaking with Josep, Export Manager at Aperam. Thank you very much for joining us this afternoon.
Hi, Robin. How are you?
Hi, I'm well, thank you. Please have a seat. First of all, I'd like to get into the name of your topic, continuous coating stainless steel for bipolar plates in PEM.
Yes.
And would you mind telling us a little bit about what is that your company does, Aperam?
Yes, exactly. So I know that Aperam is not very well known in the market of the fuel cells, but on the other hand, Aperam is very well known as a stainless steel producer. We come from ArcelorMittal, which is a very big steel maker. 300,000 people working there. So we made a spin-off of the company, and now we are roughly 10,000 people working in Aperam, and everything is related to stainless steel market.
Thank you very much. So it is a sizable company.
Yeah, exactly. The size of the company, we're a big one. Exact.
Excellent. And what is the main target of your product, the coated stainless steel?
Okay, what I'm going to do is I'm going to introduce a little presentation. Here you have it. Knowing that the main target of the car manufacturers. Oops. Okay, here. So the main goal of the car manufacturers is to decrease the price of the fuel cell stacks. So we have to keep in mind that normally in a car we have the environment which is made in stainless steel, and in the stack the bipolar plates are made in stainless steel as well, and we have roughly between 40 and 80 kilos per stack made in stainless steel. So the price of the stack it's a little bit high, so our aim was to put in the market a material which is able to give a decrease on pricing.
Are you going to the next? Okay. And can you talk about your product specifications?
Yeah, we have to keep in mind that in the stack there are what we call the bipolar plates. So bipolar plates are made in stainless steel. We have different type of bipolar plates, and who says bipolar plates, it means different functions, and it means that we have different requirements for stainless steel as well. So as you can see in my presentation there are the requirements that we need from the stainless steel. The stainless steel is going to fit to the bipolar plate requirements, but on the other hand, is not electrical conductor. So that's the reason why we are going to remove the passive layer of the stainless steel, and we are going to put a deposition on. Normally, a long time ago, this deposition was something like gold, so it was very expensive. What Aperam made is to put together a cost-efficient deposition with the right stainless steel as well.
And is this a right time to ask you about any challenges or anything that your clients always mention that they require?
Sure. Actually, okay, no, there. Okay, no. Sorry.
No problem.
Okay. Here. Okay, so normally we know that we have to obtain a good material with the right coating. The right coating till now has been always a thick one. So our strategy was first to choose a pre-coated stainless steel, because if we want to decrease the price, we have to increase the logistics, the effectivity of the line, etc. So we choose the pre-coated stainless steel. We choose also our existing mills, because like that we don't have to invest. So we are already able to produce this material. So because we already have the PVD line. And for sure we worked on an already existing coating. for other applications, but we put it for this application. So like that, we are answering to our customers' requirements when they say, okay, we need to decrease the price. Thanks to this pre-coding, which means that we are going to have less logistics, we are going to have more productivity and more time. Why more productivity? Because when we have a coil of stainless steel, for example, which is already pre-coated, you can already stamp 2 or 3 or 4, depending on your design, different bipolar plates each time. The difference is now we have the bipolar plate already coated, and before the bipolar plate was coated per batch. So it takes time, and now with this material, all this logistics disappears. We are gaining in terms of time and productivity.
So this is what happens after stamping then?
Exactly.
Great. And can you tell us expand more about the technical details of the ICR?
Yes, exact. What I have to say that before, it's that we had, because this is very nice to say like that, but we had a problem before when we were studying this material, because we have to obtain the same properties as long as the width and as the length of the coils. So that's the reason why that we have a dedicated team. So in order to develop that, we have to keep in mind that we have been studying this material for 10 years. We have an R&D and industrialization team, full sense dedicated, in order to answer to all these requirements, technical requirements that we are going to see here, as you told me.
Thank you.
So, for example, once we have pre-coated the material, we have to see the ICR. Okay, so the ICR is the interfacial contact resistance. What we do is, okay, as you see in my coil there are some lines along the width. We are going to cut this length, and we are going to measure the ICR along the width. So you see that there are different lines. The first line, which is violet, it's the ICR once we have put the coating on. The second one, it's in red. It's when we have made the electrochemical test as well, and it remains still constant. Later in green, you have once we have made the test, so the stack. Sorry, the plate. So we have the elongation of the bipolar plate, and it remains still very constant, the ICR. And after the stack test, which is made by our customers, not by us, so it remains still constant. So what we have to keep in mind, the DOE, the American DOE, they say, okay, we have to be below 10 micro ohms per square centimeter. At 100 neurons square centimeters, and we are roughly between 3 and 4. Okay, so we are below the DOE requirement.
And was there a following slide that where we could show a bit more detail?
Yes, because actually this is the theory, but we can take a look about the coding. One, we have chosen a PVD line, it's because we have a very, very thin coating, something like 100 nanometers. So that's the reason why this is cost efficient as well. And you can see there that this coating, it's continuous, it's homogeneous, it's columnar. It means that it's crystallized properly, and it's adherent to the stainless steel.
Thank you very much. And do we have another slide in that
Yes,
regard?
because normally once we have shown that, customers, they ask what's happening after stamping.
Yes.
Okay, there is any crack. Okay, here you have a furrow. You see at the top of this slide, you have a bipolar plate, and you have these 3 different furrows. I'm going to stand, if you don't mind.
No, please go ahead.
Here you will see that there are There are some small cracks. Yes, there are. So it means that the behavior of the coating it's following the stainless steel, but when the elongation is high, it's going to crack. Yes, but on the other hand, you will see here that the coating is conserved, so there's no coating consumption. We still have 100 nanometers of deposition. There's no detachment of the coating. We see it here. There's no fuel cell medium penetration either. And which is very important, what happened with corrosion? Corrosion, as I already said before, we have a passive layer. This passive layer is going to be rebuilt. We see it there. It's going to be rebuilt in order to against the corrosion to stainless steel. And this is how we are answering to this problem.
To the corrosion problem.
Exactly.
The questions I'm sure.
Yeah, because it's always the same question. What's happening after?
Yeah. Okay. Is there what is it that you would like people to take away? Oh, sorry. I should ask right now if anyone has any questions after having a look at these slides. Please, I'll come down. Thank you.
Hello, Christophe Vaquet from Forestia. A single question: what about the welding on the coating? What happened during welding?
Actually, about the welding, I'm not the right person to answer. I have my welding researcher there, and I will answer. It seems that it works well. Okay, there's no problem with welding because you know that with bipolar plates you have two types of possibilities. One it's welding, and it works. But I do not have more details. If you want, we are there, and I can show. You can speak with my technical people in order to exchange a little bit more in depth.
Thank you very much for that. Is there what would you like people to take away from this, like your main message? And
okay, yeah.
Thank you.
What I should say is okay. Why we are here showing this material? Okay, because. Aperam said we need to reduce fuel cell stacks. Why? Because we have to boost this market. How to do it? We choose the existing facilities. It means that we are already producing this material. We can send this material. We are already working with some customers. I'm not able to tell you who, because there are some non-disclosure agreements.
I was going to ask you that. Any success stories that you could share with us?
Yes, we have. We are in touch with different continents and car makers, so you can understand, but I cannot disclose.
Okay.
So it was important because it's a pre-coating material, so we are gaining in terms of production, in terms of time, money. We are doing it with existing mills, so not investment, already in our scale up. As I said, gain of logistics. Also, thanks to our PVD line, we have a very, very thin deposition on, so cost effective. For sure, we have a dedicated team for this material, so we can answer, for example, for welding, etc., etc. So, what I should say, we are ready. We are on the market, and we will scale up very, very fast.
And also stay tuned for the big news that we can't reveal just yet.
Exactly.
Thank you so much to Josep Bay from export manager at Aperam. And if anyone wants to visit them, if anyone has any further questions, or come and talk to the gentleman who can answer that question, they're in booth D66/1, which is just behind here. That's D66/1. And thanks again for joining us this morning.
Thank you very much. Thank you very much.
Thanks.
Thank you.
Thank you. Up next, we have my colleague Michael, who is here and will be talking to, with Mr. Hector Maza of Gaine Inc. And the topic will be the pressure is on 350 bar electromechanically. Thank you so much. Bye.